Welcome back. This module provides introduction to common data scientist tools. Specifically, it will highlight free and open resources and how to use them. Overview of data science tools. In this section, we will identify essential tools used for every stage of data science lifecycle. Before you jump into choosing what tools to use as data scientist, it is very important to understand and follow all the phases throughout the life cycle of data science to ensure the smooth functioning of the project. Phase 1. Discovery. It's critical to grasp the many specifications, requirements, priorities, and budget requirements before you begin the project. You must determine whether you have necessary resources in terms of people, technology, time, and data to support the project. You must also frame the business challenge and generate initial hypotheses to test during this phase. Phase 2. Data preparation. In this phase, you require analytical sandbox in which you can perform analytics for the entire duration of the project. Prior to modeling, you must investigate, reprocess, and condition data. To get data into the sandbox, you'll use ETLT, or extract, transform, load, and transform. You can use programming language such as R for data cleaning, transformation, and visualization. This will help you to spot the outliers and establish the relationship between the variables. Once you have cleaned and prepared the data, it's time to do exploratory analytics on it. Phase 3. Model planning. Here you will determine the methods and techniques to draw the relationship between variables. This relationship will serve as the foundation for the algorithm you'll use in the future phase. Using numerous statistical methods and visualization tools, you will perform exploratory data analytics or EDA. Let's have a look at the following various model planning tools. R is a complete set of modeling capabilities and provide a good environment for building interpretive models. SQL analysis services can perform in-database analytics using common data mining functions and basic predictive models. SAS or Access can be used to access data from Hadoop and is used for creating repeatable and reusable model flow diagrams. Although many tools are present in the market, but R is the most used tool. Phase 4. Model building. You'll create datasets for training and testing during this step. You must decide whether your existing tools will serve for running the model or if a more robust environment is required, like batch and parallel processing. To create the model, you look at a variety of learning approaches such as classification, association, and clustering. Phase 5. Operationalize. Final report, briefing, code, and technical papers are delivered during this phase. Furthermore, a pilot project may be deployed in a real-time production setting at times. Before complete deployment, this will provide you a good image of the performance and other relevant limits on a modest scale. Phase 6. Communicate results. It's now time to assess whether you are able to achieve the target you set for yourself in the first step. Based on the criteria defined in Phase 1, you identify all of the significant findings, present them to stakeholders, and assess whether the project's results are a success or a failure in the final phase. Category of data science tools. Let's face it, data science is a broad field, and each of its domain necessitates a different approach to data processing, which confuses many analysts and data scientists. And if you're a business leader, you would run across vital questions regarding the tools you and your firm use, since it may have a long-term impact. So again, the question is, which data science tool should you use? Diving into big data. Tools for handling big data. It is critical to understand the core concept that defines data as big data to fully comprehend the meaning of big data. This is known as the 3 V's of big data. Volume. Volume of the data defines whether it qualifies as big data or not. Variety. Variety refers to the different types of data that are out there. The data type may be one of these: structured and unstructured data. Velocity. Velocity refers to the speed at which the data is captured. This includes real-time and non-real-time data. Tools for handling volume. As the name says, volume relates to the scale and the amount of data. The technology has improved over the last decade as the amount of data has grown. Collecting and storing large amounts of data has become much easier as computing and storage costs have decreased. When we have data ranging from 1 gigabyte to around 10 gigabyte, the traditional data science tools tend to work well in these cases. So what are these tools? Microsoft Excel. Excel is the most simple and widely used program for handling tiny amounts of data. It can only manage a little more than 1 million rows, and one sheet can only handle up to 16,380 columns at a time. When the amount of data is large, these numbers are just insufficient. Microsoft Access. It is a popular tool by Microsoft that is used for data storage. Small databases up to 2 gigabytes can be handled smoothly with this tool, but beyond that, it starts cracking up. SQL. Since the 1970s, SQL has been one of the most widely used database management systems. For a few decades, it was the most common database solution. SQL is popular, but there's a problem. It gets harder to scale it as the database continues to grow. Tools for handling variety. Structured data, as you may have noticed, has a particular order and structure to it, but unstructured data has no trend or pattern to it. Customer feedback, for example, might vary in length, sentiment, and other elements. Furthermore, these forms of data are vast and varied. The two most common databases are SQL and NoSQL. SQL has been the market dominant players for several years before NoSQL emerged. Tools for handling velocity. There are several examples of real-time data collecting and processing around us. The sensor data collected by self-driving automobiles is the most complicated. Imagine being in a self-driving car. The car must actively collect and interpret data regarding its lane, distance from other vehicles and others, all at the same time. Common tools for data scientists. Data science is a broad word that encompasses a wide range of domains, each with its own level of commercial importance and complexity. You'll have a lot of questions in mind if you're starting a new data science project. Whether you're a data scientist, a data analyst, a project manager, or senior data science executive, this is true. There are a lot of free and open source tools for data science which don't require paying for them or buying any extra licenses. They also have thriving and active communities that maintain and release updates on a regular basis. Reporting and business intelligence. These technologies allow a company to spot trends and patterns in order to make important strategic decisions. MIS, data analytics, and dashboarding are all examples of sort of analysis. Excel or Google Sheets, ClickView, Tableau, Power BI, and Google Analytics are some of the most regularly used technologies in this discipline. Predictive analytics and machine learning tools. For most data scientists, this is the bread and butter of their careers. Statistical modeling, forecasting, neural networks, and deep learning are some of the problems you'll address. Python, R and RStudio, Apache Spark, Julia and Jupyter Notebooks are just a few examples. Premium data science tools. Premium data science tools that are recognized as industry leaders includes SAS. It is prevalently and commonly used in the banking and financial sectors. It has a very high share in private organizations like American Express, JP Morgan, MU Sigma, Royal Bank of Scotland, and others. SPSS. It offers advanced statistical analysis, a vast library of machine learning algorithms, text analysis, and much more. MATLAB. MATLAB is really underrated in the organizational landscape, but it is widely used in academia and research divisions. Common frameworks for deep learning. Deep learning involves tremendous computing resources and needs framework to exploit those resources effectively. Among the few data science tools in this domain are TensorFlow, PyTorch, Keras, and Caffe. Artificial intelligence tools. AutoKeras, Google Cloud AutoML, IBM Watson, DataRobot, H2O's driverless AI, and Amazon Lex are some of the most popular AutoML solutions. AutoML is expected to be the next big thing in the AI or ML world. For business leaders to use it to make strategic decisions, it seeks to eliminate or reduce the technical side of things. You have come to the end of Module 7, Data Scientist Toolkit. Here are our takeaway points from this module. There are a variety of tools available for each stage of the data science lifecycle. These tools combine computer science, statistics, predictive analytics, and deep learning to drill down into complex data by extracting, processing, and analyzing structured or unstructured data to efficiently provide meaningful information. To produce real values for a project, it is critical to use the correct data science software and tools. Nevertheless, the context in which data exists is interdependent on the data scientist. Congratulations! The final module for the Data Science for Beginners course has been finished. Thank you for taking part in the course and putting forth the effort to complete it. Because this course is a prerequisite for other data science courses, I hope you don't forget what you've learned and accomplished.